Alright guys, we're solving systems using substitution. You know that you should use substitution to solve a system if one of the variables is already isolated. And so we are going to look at equations where one of the variables has already been isolated, because that's when you use substitution. The steps for solving a system of equations using substitution is the first step is to isolate one of your variables. So get one of your variables alone. Like I said, all of our examples already have one of the variables isolated. But if you didn't have one of your variables isolated, you would want to solve for one of them. The second step is to plug the solution from step 1 into the other equation. And what happens then is that you end up with an equation that only has one variable. Only one variable, and that's very important that you only have one variable. What we do at that point is we solve that for that variable, and we get a numeric answer. So we're going to get x equals 5 or y equals -6, something like that, where you get x or y equals a number. Okay. After you get that first solution, you're going to plug your numeric answer into the equation from step 1 and solve for the other variable. And what we're going to do here, guys, is we are going to go ahead and work through some examples. I'll work through number 1 with you, but I want you to pause the video then, and I want you to work through 2, 3, and 4 on your own and see if you are getting the right answers or getting answers that look right. And then you can unpause the video and see whether or not your answers are right. So I will work through 1, and then I want you guys to work through 2, 3, and 4 on your own before you watch the video. So step 1 says isolate a variable. I don't have to do that here. X is already alone. What I am going to do is I'm going to take the -4y plus 2, and I'm going to plug it in for x. And so instead of the x right there, I'm going to have the -4y plus 2. It is extremely important, guys, that when you are doing this, you put parentheses around the thing that you've plugged in. So I have a 2 that comes from that equation, and then the -4y plus 2. The plus 6y that comes from this equation is equal to 2. Okay, and so it is very, very important to put this -4y plus 2 in parentheses. If you don't, you are at risk of forgetting to multiply this 2 times the 2 over here, and you are also at risk for sign issues if there were a negative sign out in front. So please remember to do that. At this point, I have an equation that only has y's in it, and so I can solve for y, and I'm going to do that by distributing the 2. And so we get -8y plus 4 plus 6y is equal to 2. And so I've got, again, just an equation with only y's, and so I can combine like terms. This is -2y plus 4 is equal to 2. Subtract the 4 from both sides, and I get -2y is equal to -2. Divide both sides by -2, and I get y is equal to 1. And that is half of my solution, so I'm halfway there. And then, guys, what I'm going to do is I'm going to take that y equals 1, and I'm going to plug it into my first equation, the x equals, because that's going to give me the answer for x very quickly. So this is -4y plus 2, and remember that I know that y equals 1. And so this is x is equal to -4 times 1 plus 2. So x equals -4 plus 2, which means x equals -2. And so the solution to this system is -2, 1. Alright guys, pause the video here and work through the other problems, and then come back when you're done to check your answers. Alright, for -2, or for number 2, not -2, for number 2, we are going to take this y equals -3x plus 16, and I'm going to plug it into the second equation where y is. So I've got the -3x plus 16, because it's y equals, I'm going to plug it in for y. And so this equation is going to be 2x minus 3, parentheses are so important, guys, minus 3 times -3x plus 16 is equal to -4. And so I took out the y and I put the negative 3x plus 16 in. And so now I'm going to distribute the negative 3. I've got 2x plus 9x minus 48 is equal to negative 4. And if you'd forgotten those parentheses, you might not have multiplied that negative 3 by the 16, and that would have been a problem. All right, kids, so this is 11x of combining like terms minus 48 is equal to negative 4. I solve for x by adding 48 to both sides. And I get 11x is equal to 44. Divide by 11. I get x is equal to 4. All right, I've got half of my solution there, kids, and so I'm going to find the other half, and I'm going to find that by using the first equation, the one where y was isolated. Y is equal to negative 3x plus 16, and I know that x is equal to 4. So this is y is equal to negative 3 times 4 plus 16. Y is equal to negative 12 plus 16. Y is equal to 4. And so my solution here is 4, 4. Isn't this fun, guys? All right, let's look at numbers 3 and 4 now. Again, these are systems where one of the variables is already isolated. So here y is isolated. So what I do is I take that 3x plus 7, and I'm going to plug it in for y in this equation. So the new equation is 6x minus 2, and then the 3x plus 7 comes from right here. So times 3x plus 7, y'all, parentheses are so important. Parentheses are so important. And what I have now is an equation that only has one variable in it. So I'm going to solve for that variable, and I do that by distributing the negative 2. So this is 6x minus 6x minus 14 is equal to 5. And there's something very interesting going on here, which is that my x's cancel out. And when my x's cancel out, what I am left with is 0x minus 14 is equal to 5, and that's just negative 14 is equal to 5. And if you are freaking out right now, go watch the video about types of systems of equations, because we talk about this on that video. But what I have here is a false statement. It's false. Negative 14 is not equal to 5. Negative 14 is equal to negative 14, and 5 is equal to 5. They're not equal to each other. And when we end up with a false statement, what that means is that there is no solution. No solution. And we actually like these systems because, look, guys, we didn't have to solve for a second variable. Look how easy that was. All right, I'm going to solve number 4 right now. So I've got y isolated already. And so I'm going to take this negative 4x plus 7, and I'm going to plug it in for y in this equation right here. And so it's going to become 2x plus 5 parentheses, negative 4x plus 7 is equal to negative 1. And I'm going to distribute the 5. And so I get 2x minus 20x plus 35 is equal to negative 1. And this is negative 18x plus 35 is equal to negative 1. I can solve this equation for x. So I subtract the 35 from both sides. I get negative 18x is equal to negative 36. Divide by negative 18. I get x is equal to 2. So it's one of my solutions, and what I want to do is I want to go ahead and plug that into this other equation where y was already isolated. So y equals negative 4x plus 7. And I know that x equals 2. So y is equal to negative 4 times 2 plus 7. Y is equal to negative 8 plus 7 y is equal to negative 1. So the solution here is 2, negative 1, like that. All right, guys, again, just in case you were confused by this right here, go back and watch that video about types of systems, because we talk about that there.